Here's a straight line, and if we need to find the equation of it, we can use y equals mx plus c, where m is the gradient and c is the y-intercept. To work out the gradient, we take any 2 points, see what the change in y is, which is 3, what the change of x is, which is 1. So the change in y divided by the change in x is 3 divided by 1, which is 3. So the equation of this line is y equals 3x, and then the plus c is the y-intercept, which is minus 1. Now notice that the gradient of this line is the same at any point because it's a straight line. That's so important, I'm going to say it again. The gradient of this line is the same at any point because it's a straight line. It's always 3. Wherever we took a little triangle, we'd always get 3 divided by 1. Here we've got the graph of y equals x squared, and this is obviously not a straight line. So the gradient changes at different points. The steepness of the line changes depending on what value of x we've got. What we're going to look at is the gradient around this point here, which is where x equals 2 and y equals 4. I'm going to start by saying that the gradient of this line, which is about like that, is going to be approximately equal to the gradient of this chord. How do we work out the gradient of the chord? Well, it's the difference in the y's divided by the difference in the x's. The point up here is at 3, 9. The point here is at 1, 1. So the change in the y divided by the change in the x is 8 divided by 2, which is 4. So we're trying to find the gradient at this point here. That point there has got coordinates 2, 4. So I could take a smaller gap. I could, instead of going from 1 to 3, I could go from 1.9 to 2.1. I know that's 3.61 because 1.9 squared is 3.61. The equation of the line, remember, is that y equals x squared. So if I square 1.9 I get 3.61. 2.1, that's 4.41, because if you square 2.1 it's 4.41. So what's the difference in the y's divided by the difference in the x's? I'm just going to write d now because I can't be bothered to write difference and change. So the difference in the y's is 4.41 minus 3.61 over 2.1 minus 1.9. 4.41 over 3.61 is 0.8. 2.1 minus 1.9 is 0.2, so that's 4. That's the same answer as we had before. So we can make up a table, and when we know that when x is 2, the gradient is 4. Now we could do the same experiment and the same investigation with other x numbers, and what we'd find is we got these numbers here. We'd also find it works for negative numbers, and it also works at 0. Why does it work at 0? Because the graph is y equals x squared, and at this point here the gradient is 0. So what we've got is that the gradient is twice the x number. So the gradient, which is the change in the y divided by the change in the x, is always 2 times the x number. Here's the graph of y equals x cubed. So let's find out the gradient of y equals x cubed at the point 1, 1. So what we're after is the gradient of that red line. So let's do what we did before. Let's take a point just below, that's 0.9, and take a point just above, that's 1.1. To work out what the y numbers are, we can use the fact that y equals x cubed. And so we get 0.729 and 1.331. So let's do a dy and a dx. dy is the change in y, the difference in the y's. dx is the difference in the x's. Well, 1.331 minus 0.729 is 0.602. and 1.1 minus 0.9 is 0.2, so we get 3.01 for the gradient at that point. Now what we would find is that if we took even closer intervals, instead of going from 0.9 to 1.1, we went from 0.99 to 1.01, this number would get closer and closer to 3. So we can do the same thing as before and draw up a table. So we know that when x equals 1, dy by dx equals 3. And what we would find is we'd get a series of numbers that look a bit like this. So what we need to do is to try and find the connection between the x number and the dy by dx. And what it works out to be is that dy by dx is 3x squared. So we can check that. Square 2, that's 4, 3 4s are 12. Square 3, that's 9, 9 3s are 27. So what we've got so far is this table. If y is x squared, the gradient function is 2x. If y is x cubed, the gradient function is 3x squared. If it was x fourth, we would find that we'd get 4x cubed. If it was x to the power 5, we'd find it's 5x to the power 4. What about if it's x to the n? I'm pausing to let you think about it. Then you'd find it's nx to the n minus 1. Now what we'd also find, if we did more investigations here, that if we had 2x squared, it would be 4x. If we had the gradient function would be 4x. If it was 5x cubed, the gradient function dy by dx would be 15x squared. If it was 21x to the power 4, it would be 84x to the power 3. So if it's if y equals ax to the n, then dy by dx is n times a times x to the n minus 1. Now this is a fundamental and absolutely very important rule that we're going to be using for the rest of your maths course.